Hi, welcome back to part 2 of arc length for multivariable. In example number 3, we are looking for where on this curve we are we after traveling for a distance of pi root 10 over 3 units. Now we saw this example, this problem example number 1. This is a spiral starting from the YZ plane heading parallel to the x-axis, parallel to the x. So if we were to take a look at this, again, I want to just like to graph it. So remember, we're starting on the YZ plane, and we're spiraling out parallel to the x-axis right there. And we stop. So we're starting here at t equals 0. They're telling us we travel a distance of pi root 10 over 3 units. And we want to find out where this point is, this x, y, z is. Now you may notice, in order to get that point, all I need to do is find t. If I can find t, I can get the point. So that's our ultimate goal, to find t. In other words, how long did it take us to get there? So remember, what we're looking for is a position, basically. So here's what they tell us. We're starting at t equals 0. Well, we don't quite know how long it takes us, so we're going to keep that generic. So I'm going to give me some generic domain here. The domain from 0 to t. You can make that variable anything you want. I'm going to make it t just to kind of keep it simple for us. So it helps me know what I'm looking for. Alright, so let's see here. Well, I know the distance I've traveled. That's another word just for length. And we know how to find length. From the previous page, we found length by using our our little arc length formula right there. So I know to get my length, I can integrate this from a to b, the magnitude of r prime of t dt. I know what a is, and I kind of know what b is. B is just t, and that's okay. That's going to be again like our example number 2, where we actually found the arc length equation for us. All I need to know now is r prime of t, and I can get that by taking my derivative. We get 6 cosine 2t, negative 6 sine 2t. And when I write out my length formula, my arc length formula now, we go from 0 to t, a to b, times the magnitude of r prime of t. And we're going to do this in our head, the magnitude. Let's see if we can do that magnitude real quickly. Ready? R prime of t. We'll do that. We can do that in our head. Some of you guys can. This becomes 4 plus 36 cosine squared of 2t plus 36 sine squared of 2t. Yeah, I'm going to need a longer bar there. And of course, that's just the square root of 40. Now, that finds my length. But I already know how far that length is, that distance traveled. That's that pi root 10 over 3. We found that they told us that. So now all I have to do is solve our equation. If I were to integrate here, we get the square root of 40. T from 0 to t equals pi root 10 over 3. Using our fundamental theorem, this is just 40, root 40 times t. The 0 doesn't matter, and that's going to equal pi root 10 over 3. And I can divide. T equals pi root 10 over root 40 times 3. And this can simplify pretty nice. This is just becomes 1 over 4, which is 2, 1 over root 4, which is 2, times 3 is 6. So we get pi over 6. So this is telling us to go from this point to here, at this point right here, t equals pi over 6. It tells us how long we took there. So now I can find my position by plugging in t into our equation. R of pi over 6. And let's see what we can do here. That's just, what's that, pi over 3? Yep. This becomes 3 times the pi over 3, which is root 3 over 2. And this becomes 3 times cosine of pi over 3. Remember, this is pi over 6. By plugging in, it becomes pi over 3. And that becomes 1/2. And there is our position. Hope you guys enjoyed that problem as much as I enjoyed giving it. It's a kind of neat little problem. You will see this on a test, and you will see this on a quiz. All right. The next one's going to introduce us to graphing these, sketching a space curve. And this is a little bit tricky. We're going to take a look at a bunch of these. Maybe another video we can take a look at some more. So we're going on a trip on our favorite rocket ship. Our rocket is out of control, and it is following the path laid out by the following trace. So we want to sketch this. In order to sketch this, I'm going to do a couple of things. First thing I'm going to do is I'm going to start with the XY plane. This is almost like a projection. So this is coming out a graph in space. So I'm going to look at the projection only on the XY plane. In other words, I'm going to pretend like Z is just 0. So I'm looking at a graph only on the XY plane. And that's where I start. Okay? If I start on the XY plane, I know that X is T, it's a parametric, Y is 4/3 T to the 3/2. I can write this as a function by replacing T with X. So Y would equal 4/3 X to the 3/2. And I want to see what this looks like. So let's see what this looks like on the XY plane. On the XY plane, I don't have to worry about negative x's. There's going to be no negative x's here because I'm taking an even root. So what does x to the 3/2 look like? Well, I might have forgotten that, but that's why, we have calculators. Oops, excuse me, getting ahead of myself there. That's why we have calculators. So if I forgot what x to the 3/2 looks like, so I can graph that. X to the 3/2, so 1.5. And there's our graph, opening up towards the y-axis. So it's going to look like this somehow, like this. And it does keep going forever. So I'm going to transfer that to my 3D space curve now. There it is. Opening up like this. Remember, there's going to be no negative x's. Now I am going to look at the z's. Next, look at the z's. So they're telling us z is given by this, 1/2 t squared. Notice this is parabolic right there. That's a parabolic graph. So what this is telling me is at t equals 0, I know z is 0. So I know I'm starting at the pole, the origin right there. But what happens as we go along this curve? Remember, we're traveling along this graph right here, but we're adding height to it. That's what this says. I'm adding height. But my height is parabolic. It's not like a line. So what happens here is on our trace, because this is parabolic, we're going to draw a curved parabola over or on, using, the xy trace that we just found. So in other words, from here I'm going to draw a parabola going up. So I'm going to pick points. Doesn't have to be too much. So now it's a parabola, so remember each little, so from here, so I'm pretending like this is like my, if I draw a parabola on the xz plane, I can draw a parabola. But what if the xz plane were curved? So it's like I'm taking my x-axis, and I'm curving it, and I'm drawing a parabola kind of going up. And I can trace this. So I'm starting here. Missed it. And it's curving. So you can kind of imagine in red, this is our trace. right there. And that's what this is. This, remember, this is a trace in 3D. So you can kind of imagine on the XY plane, if there's like, I imagine like this being a wall right here, and we're just looking at the top of the wall as it kind of scales down to the ground. So you can kind of climb that. These are a little tricky to do. They do take some practice. We'll take a look at some examples more later on too. Now the next part says we want to find the length of this rocket. So now we want to find the length of that path. So we do have a formula for that. L equals, from 0 to 2, we want the magnitude times of the magnitude of r prime of t dt. So we need r prime, of course. So let's go ahead and get r prime of t. That's not too bad to do. This just becomes 1. Oh, this one's pretty nasty. The 3's are going to cancel. The 2 makes that a 2. So we get 2t to the 1/2, and this just becomes t. So to get our length, we're going to go from 0 to 2. We're going to look at the magnitude of this, which is 1 plus, that just becomes 4t plus t squared dt. Not by hand. Okay? Use a calculator or a technical tool, like a computer tool. So, alright, so I am going to calculate this integral. So I'm going to go to my home screen, homies. Menu, I'm using my Inspire. Calculus, I'm looking for the integral. And I can just type that in, 0 to 2. And I type in exactly as it looks. The square root of 1 plus 4t, I can even use t, plus t squared and t. If you prefer x, that's okay too. Press enter. And I get this nasty little answer. That's one of the bad things about the Inspire, right? So let's see here. Let's see if we can change this to a decimal. Control, enter, and I get this answer that's much nicer. 4.816, basically, units. Please do not leave your answer as that one. Please don't do that. No, wait, I mean, look at that thing. Nasty. All right. So over here, if you notice, so this path as it's arcing up is 4.81, about 4.816 units. All right, go to video number 3, and we have one more example for you.